Okay, I'm going to go through this problem fairly quickly, so pause the video and take some notes when you need to. If you divide p of x by d of x, you actually get what's called a rational function. And if you graph it, you'll find that there's a vertical asymptote when x equals -4, because the function is undefined when you try to put -4 in for x, because you'd be dividing by 0. Now you're asked to write it in the form q of x, which stands for the quotient, plus the remainder over the divisor. And since we're dividing by a binomial where the leading coefficient is 1 and the degree is 1, we can use synthetic division also. But here's long polynomial division. X plus 4 divided into the dividend, 3x cubed plus 9x squared minus 6x minus 1. The way that you do this is like long division with numbers, sort of. You picture dividing x in, oh, by the way, you need to put placeholders in here if there's any missing exponent. For example, if there was really no 9x squared term, you'd have to put a 0 here. So you need a placeholder for every exponent, but there's none missing here. Same for the divisor. But x goes into 3x cubed. Here's what you're visualizing. 3x cubed divided by x, the first term of the divisor, gives you 3x squared. Which you textbooks put x squared. You like to put it out here front. And now you take this 3x squared times each term and write it underneath the terms of the dividend. So the key is that 3x squared times x is equal to the first term of the dividend, and 3x squared times 4 is 12x squared. Draw a line, and now you subtract this polynomial from the one right above it. When you subtract, you mentally change the sign. So just for emphasis of each term, there's mentally me changing the sign on the 3x cubed that we're subtracting, combine it with the term above, and we get 0. There's no reason to write the 0 there. And mentally, we change the sign of the plus 12x squared to minus 12x squared and combine. 9x squared minus 12x squared is minus 3x squared. Bring down the next term and repeat the process. So x goes into -3x squared, -3x times, multiply, you get this. Mentally change the signs and combine. That's really a subtraction. -6x plus 12x is 6x. Bring down the -1. X goes into 6x 6 times. 6x plus 24. Mentally change the sign. I'll do that for emphasis right here. And -1 plus a -24 is -25. That is the remainder. And so that means you can rewrite this rational function right here like this. 3x squared minus 3x plus 6. That's the quotient. That's the q of x in the way they pose the problem. Plus the remainder, which is -25, over the divisor, which is x plus 4. Okay. Now, if you want to use synthetic division, in this little block right here, you put this -4. In other words, you have to have a minus sign between the x and the constant. So if this was x, if we were dividing by x minus 4, this 4 would go on the block because we have a minus sign right here. And then you write down the coefficients in descending order of the dividend. And again, you'd still need a placeholder. If this 9x squared wasn't here, you'd put a 0 here instead of a 9. But the way you do it is bring down the leading coefficient, multiply. So -4 times 3 is -12. And add. 9 minus 12, negative 3. Repeat the process. Negative 4 times negative 3 is 12. Add. So multiply and add. And finally, there's the remainder. Okay. And same deal. You can, well, I should have not have used the letter Q. I'll just use a little letter f of x equals the quotient plus the remainder over the divisor. And by the way, you could have factored a 3 from the quotient and written it this way. And you could even, no, you can't. That would be it. And here's kind of proof. There's the original function. There's the g of x. There's q of x where I factored out 3. I made up a table for each of those functions and put in some values. And there's the graph. If you go to Desmos, these graphs will all overlap because they give you the same exact function. Okay, and I'll provide a link to that Desmos graph in the answer. There you go. Hope that helped. If you have any questions, post a comment.